Hi everyone! In this video, we're going to learn about trigonometric functions. But first, let's do a quick review of a general notion of a function. So, what is a function? In short, function is a relation, but this is not a complete definition. I'll tell you the rest in a minute. I like to think about a function as the box or a machine, such that certain values get into that box, and those values we call inputs, and often denote them by variable x. And function relates this input to what will come out of that box, or output. And here's the rest of the definition. Only relations such that for every input, there's only one corresponding output. Those relations are called functions. And let me remind you that all possible inputs of a function we call the domain of that function, and all possible outputs are called the range of a function. We study functions in algebra, algebraic functions, and trigonometry, trigonometric functions. And in general, the definition of functions is the same in both branches. However, there is one difference when it comes to trigonometric functions. In algebra, functions relate real numbers. For example, if we take function y equals 3x plus 1 and pick an input, let's say 2, and I'm going to say x equals 2, then to determine the output, we simply have to substitute 2 for x into this function. So what will we get? It's going to be 3 times 2, which is 6, plus 1, we get 7. So basically in algebra we have functions represented by equations, and those equations determine outputs based on the given input. But in trigonometry, functions relate angle measures with real numbers. And how does that happen? Well, there are 3 basic trigonometric functions: sine function, cosine function, and tangent function. And given an angle, each function determines what's going to be the corresponding real number, the corresponding output. But how does that happen? Well, let's talk about that. One definition of trigonometric functions applies to acute angles in a right triangle. The right triangle that you're looking at has, of course, one right angle and 2 acute angles, angle A and angle B. So we can define trigonometric functions for one of those 2 acute angles. Let's say it's going to be angle A. Before we look at the definitions themselves, we need to label sides of this triangle. You know that the side that's opposite the right angle is called hypotenuse, but we're also going to label side that's opposite of angle A that we picked. Well, we're simply going to call it opposite side, side BC in this case. And the third side, we're going to call adjacent side. Well, because it's adjacent to angle A, it's actually one of the sides of that angle, right? And this is how sine of angle A is defined. It's a ratio of the side opposite angle A to the hypotenuse. Remember we said that trigonometric functions relate angle measures to real numbers. So angle A has certain angle measure, and a real number that sine function relates to angle A is the number that we get by taking the length of the opposite side and dividing it by the length of the hypotenuse. So that's where the corresponding real number comes from. In short, we say that sine is the opposite side to hypotenuse. Now, cosine and tangent functions are defined in a similar way. They just relate different sides. Let's look at those definitions. So cosine of the angle A is the ratio of the side adjacent to angle A to the hypotenuse. Adjacent to hypotenuse. And finally, tangent. Tangent is the ratio of the side opposite of angle A to the side adjacent to angle A. Opposite to adjacent. So these are the triangle-based definitions. And while the idea of each definition is not that hard, what's going to be important to remember these definitions and use the correct sides in each ratio. Well, there's one trick that a lot of students use to remember those definitions, and this is how it goes. So you basically take the first letters from each definition. Sine is the opposite side to hypotenuse, SOH, and you get something that sounds like SO. Cosine is the adjacent side to hypotenuse, CAH, or CAH. And then tangent is the opposite side to adjacent, TOA. And altogether it becomes SOH-CAH-TOA. And while these words, if you can call them that, have no meaning, a lot of students find them easy to remember, SOH-CAH-TOA, and they help to remember definitions. Let's practice what we just learned. So in this example, we have a triangle with all three sides labeled, and we need to find sine, cosine, and tangent of angle B. And let's use SOH-CAH-TOA to help us. Before we start forming the ratios, let's label sides of this triangle. First, let's start with identifying the hypotenuse. Well, it's always opposite the right angle, so that must be the hypotenuse. Now, let's determine side opposite angle B. Well, I just have to go straight from angle B, and then I'll reach the opposite side, so it's 5 units. And the side that happens to be one of the sides that angle itself, and not the hypotenuse, is the adjacent side. Okay, now we're ready to set up the ratios. Sine. Okay, I'm looking at SOH, S-O-H. S stands for sine, O stands for opposite, H for hypotenuse. So that reminds me that sine is the ratio of the opposite side to hypotenuse. That means that we're going to get 5 in the numerator, the opposite side, and hypotenuse is 3 squared of 5. Like that. And that's what sine equals to. The only thing I'm going to remind you that it's common not to leave any radicals or square roots in the denominator. And as you can see, we have square root of 5 in the denominator. When that happens, we usually want to rationalize the denominator. You may remember from algebra that to rationalize the denominator means to get rid of that radical. And when we have square root, it's actually pretty easy to do. We simply need to multiply by that same radical on the bottom and on the top. And we do that because when we multiply radical by itself, it basically disappears, because what is square root of 5 times square root of 5? That is same as square root of 25. Okay, so what we're gonna get is 5 square root of 5 in the numerator and 3 times 5 in the denominator. I can see that this quotient can be simplified even further. I can divide out 5. So that gives me the final result, square root of 5 over 3, like that. So that's what sine of angle B equals to. Let's move on and find cosine. So I'm looking at my hint here, CA, C for cosine, A for adjacent side, H for hypotenuse. So it's adjacent to hypotenuse. Okay, so adjacent side is 2 square root of 5 and hypotenuse is 3 square root of 5. And I can see that in this fraction, square root of 5 can be divided out. So the final answer is 2 over 3, 2/3. That's the cosine value of angle B. And finally, tangent. TOA stands for definition of tangent. So it's opposite side to adjacent. Now, we already said that the opposite side is 5, and the adjacent side is 2 square root of 5. Now, again, I have square root in the denominator. It has to be rationalized. I will multiply by square root of 5 in the denominator and in the numerator. That will give me 5 square root of 5 in the numerator, and then that is 5, right? So 2 times 5 in the denominator. I can divide out 5 in this fraction. So the final answer is square root of 5 over 2. That is tangent value of angle B. So this is how we define and find values of the 3 major trigonometric functions. But we have 3 more functions, and they're called reciprocal functions. So each of the 3 major trigonometric functions has a reciprocal. Let's quickly review reciprocals. So reciprocals are 2 numbers or expressions such that when we multiply them, we get 1. But you may remember that when we use reciprocals in algebra, we use the trick to find reciprocal very quickly. So let's say if I have fraction 2 over 3, its reciprocal will be fraction 3 over 2. I just simply have to flip the original one. And as I check, 2/3 times 3/2, when I multiply those two, I'll get 1. Easy like that. And let's refresh how we find reciprocals for whole numbers. For example, 5. Well, To flip that, it's going to be easier to put in a fraction form first. So 5 is same as 5 over 1. And then I'm ready to flip it, so it's going to be 1 over 5. So reciprocal of 5 is 1 over 5. And with that, we're ready to define reciprocal functions. Here they are. We have secant function, which is reciprocal of cosine. We have cosecant function, which is reciprocal of sine. And we also have cotangent function, and that is reciprocal of tangent. And then since they're reciprocals, I can also define them in terms of sides of a triangle. For example, secant is hypotenuse over adjacent side, because remember, cosine is adjacent side to hypotenuse, right? I just flipped that fraction. Remember that sine is opposite side to hypotenuse, but cosecant will be reciprocal of that hypotenuse to the opposite side. And since cotangent is the reciprocal of tangent, cotangent is defined as the adjacent side to the opposite. Now, idea of reciprocals is not that hard. Maybe it's remembering which reciprocal goes with which function. That's going to be a little bit more challenging. And for that, I use the following trick. Well, first of all, remembering that cotangent is reciprocal of tangent, I think is, pretty easy. They sound very similar, right? Cotangent, tangent. But the other two, well, for those who need something to help us remember. And this is what I do. I just remember that reciprocal functions never start with the same letters. So if I'm looking at the secant function, I know that its reciprocal has to be cosine. It cannot be sine because, again, I remember that they have to start with different letters. And notice that it works the same way for cosecant and sine. They start with different letters. And that's how I remember them. So let's go back to our example and now find the reciprocal function values for angle B. I'm going to start with secant function. Secant function is the reciprocal of cosine. Well, and since I already know that cosine is 2/3, finding its reciprocal is going to be very easy, right? What is reciprocal of 2/3? It's 3/2. That means that secant of angle B is 3 over 2. Simple like that, and here's that answer. Now let's try it with cosecant. Cosecant is the reciprocal of sine. Now I also have sine value, and technically I just need to take its reciprocal. If I take my final answer here and obtain its reciprocal, square root of 5 will end up being in the denominator, and this means that I will have to rationalize the fraction, which is, not a big deal, but if I can avoid it, I'd rather save time. So to save time, and if I know that I had to rationalize the denominator when I was obtaining sine function value, what I'll do, I'll go to the original ratio that was not rationalized, because now if I take that ratio and I find its reciprocal, square root will appear in the numerator, and I'm going to be good to go. In other words, instead of using the final answer, I'm going to use this ratio, and once I obtain its reciprocal, 3 squared of 5 over 5, that's going to be the value of cosecant function. But if I decided to go with the final version of the sine function value and obtain its reciprocal and then rationalize the denominator, I would get exactly the same result. So that means that you have options here. And finally, let's obtain cotangent of angle B. Cotangent is the reciprocal of tangent. Again, if I go with the final version of the tangent value, then I'll have to rationalize the denominator. So I'd rather go with the original ratio. Its reciprocal is 2 squared of 5 over 5. That will be the cotangent function value. And this way we were able to obtain all 6 trigonometric function values of angle B.